you are here to be a DevOps engineer, you want to learn DevOps. Okay, you want to be a DevOps engineer, an architect, and a DevOps consultant, anybody, right, in the DevOps field. So you must be searching already, I know, going through different things. There's so many courses. If you search on Udemy DevOps, you will see a lot of different courses. If you Google, you have Jenkins, you have Ansible, AWS, Kubernetes, Docker, so many technologies, which really confuses you, which technology should I learn or which I should not learn, because it's not so easy to learn all these technologies. And every day you will see new technologies coming up in the automation, right? You have Terraform, now you have AWS CDK, and so many technologies, so it confuses you more, right? So I will explain you what really is DevOps and which technology to focus on, which should not focus more on. My name is Imran Teli. I have experience in I have 11 years of experience in the IT industry. I have worked as a systems engineer, cloud engineer, DevOps consultant, DevOps trainer. I wore different hats. I've been seeing this industry's evolution in DevOps from the beginning of it. Okay, so what I learned as a system administrator, as an automation, as a cloud engineer, there are a lot of ideas that I got and which I implement in the projects, and the same ideas that I try to teach in the course. And also I have created a Udemy course, which is advanced level course for the projects, how you can handle a DevOps project in different ways by using different various other technologies, right? So I have implemented all that. I have certified, I have done a lot of certification, to be frank. I'm a Red Hat certified architect. I'm certified in Ansible, OpenStack, which is a Kubernetes actually, GlusterFS, sorry, OpenShift, which is Kubernetes, OpenStack, which is storage technology, Gluster, Puppet, and many more other certification. You can check my LinkedIn profile to see more in detail. In AWS, I'm certified in SysOps, DevOps, and also security specialist. Right. So this course that you're going to learn from me in DevOps is not just a DevOps course. It's AWS plus DevOps. Okay. So we're going to use AWS cloud computing solution safely, securely, right? And we're going to do lots of automation. In my distance past, and I have done some other certifications also in DevOps Foundation, VCP, VMware, RSC, Python from EDX, and there are a few more. It's just too much to put in. If you have any question regarding certification, which one to do, which I should not do, so you can ask me at the end of the demo. I will answer the questions on the certifications. Okay, so I have expertise and knowledge in DevOps, cloud computing, collaboration, collaborating between teams and tools and technologies, and lots of scripting. All right. So it's all about my passion towards training, that I have come in the training area. I used to train people from the very beginning of my career in technologies that I learned, and I would like to share. I was very interested in sharing it, so that's how I came in training. So it's really a passion, not some job to earn some extra bucks. Right? I have few other training programs and projects that I have launched, which I'll be talking about in the course. Right. So why should you learn DevOps? There are so many reasons. Everyone have their own reason, and that's good, right? But I always say you have these three good reasons that I put forward, not only for DevOps, for any technology that you're learning. One is it is one of the top skills in the IT industry. Frankly, you are here attending the demo because you already know, you heard about DevOps, and people are going all crazy about DevOps, right? So you check Forbes magazine, you see Business Insider News. There'll be so many articles and blogs and so many big company contributing to DevOps projects, right? So it's one of the top skills that employers are looking really, but that there are not quite many DevOps engineers yet. Okay, so doing a technology that is talked about a lot in the market is a safer approach, right? It's also one of the highly paid job as per the survey. Check Indeed, check Glassdoor, right? Put a question on Quora, right? I have seen DevOps engineers earning much more than developers and other. Sorry, I don't want to degrade other job roles, but the demand is so high that people are ready to pay more money than existing careers, right? Now, the third reason is the most important reason over here, and which is, from a long time, IT industry is divided into two zones: development and operations, right? Developers and build and release and testers, you have these teams, different teams in development area. They're responsible in creating the software, right? They create and test the software. On the other hand, the operations team is responsible in delivering the software. Okay, it's the same thing. Like there is a industry, any kind of industry, manufacturing industry, which manufactures some goods and then it supplies to the market, right? The industry will only make business if it's able to uh, send, right, or ship its product to the retail market as soon as possible in a better quality, in a better shape. Okay, and when it reaches the retailers, that's where they make money, right? It's same with the software, right? The developers, testers, these people create and test software, but if we are not able to properly deliver the software, you don't make business, right? So from a long time there is a huge gap in between development and operations. Okay, so development part develops the software, operations delivers it, right? So there is a huge gap from a long time, and DevOps will fix that gap. It will make the delivery smooth, faster, and more efficient, more error free. Okay, so you can make more business. So every company who is in the IT industry, who is in creating or delivering the software, would like to implement DevOps. Yes, for sure. If not today, definitely tomorrow or day after tomorrow sometimes. So everybody in the IT industry needs DevOps engineer, consultant, architect. So there is a huge scope, okay, to get a job or highly paid job. Right. Third reason is the most important reason. Right. So DevOps is not a tool or a technology that can expire, right? You learn in few minutes that what really is DevOps. So my point is everyone needs DevOps today. Okay, small scale, medium scale, large industries, everyone needs DevOps, right? So why me? There are so many courses in the market, right? Let me tell you a few more things about myself. I have trained thousands of candidates in DevOps, which who are already working in the IT industry. I focus more on the real-time implementation that you will see in the course, and also my projects that I have created on Udemy. Right, so the way we are going to learn a concept or a tool or a technology is by taking a real-time use case, right, and solving that problem by using some tools and process and concepts. Okay, so my focus is going to be on real-time implementation. Right, I will teach you how you can excel in software delivery. The most important part which people miss, they focus more on tool, but I focus tool plus their integrations. Okay, so then you can create a software delivery mechanism. Right, so I'll show you the technologies and concepts that big tech companies uses. Right, I'll show you how multiple technologies work together. There are so many people who have learned some tools, they still join the course because they just know a tool but they don't know how to integrate it with all the other several automation tools. So I'll show you how you can take multiple technologies, integrate them together. Okay, and I really have put a lot of efforts in creating the practicals, the scripts, the exercises, projects, documentation, interview questions that I'm going to talk throughout the course. Okay, so yeah, a lot of really real lot of materials over here. Okay, all right, so now if I made my point why you should learn DevOps, let's see what is DevOps. Okay, now different people have different explanation on DevOps, and that is because people are coming from different background. They have their own perspective, right? And operations system admins will say DevOps is all about scripting and automation, right? But if it's really about scripting and automation, then it's been there from long time, right? But nobody used to call it DevOps back then. It was just automation and scripting, right? People who are in cloud computing, they feel that DevOps is about cloud computing. Okay, trust me, it's not just about that. There are many more things about it. And people from a management point of view will say that DevOps is about culture, right? Process oriented, who should do what, right? That kind of thing. If really those are the things, then why there are so many tools, right? If it's just about the culture, right? And yes, there are so many tools. You already know that, right? So which tool to use, how to integrate, what process to apply. So we'll understand all this, but there are so many explanation, and these are the myths actually. The real DevOps will understand what it is. Okay, and to make you understand, I'm going to set a story, right? And everyone likes a story, right? Everyone likes story, right? So I'm going to tell you a story, very nice story with some explanation, of course. Okay, anyways, I'm going to tell you whether you say it or not. Okay, so here I go. So we have to understand first the software life cycle, how a software from an idea gets created and delivered in the market, and what are the problem that comes in, and how we can solve that problem by implementing DevOps. Okay, So little background, right? So let's say there is a great idea someone gets. Okay, let's say Penny has a great idea to develop a mobile app for her exhibition that that she has. Okay, she is into arts, right? She create art pieces, drawings, and so many other art things, right? Art things, really. Yeah, so she has a shop, right? And she sells it in the local market. She's quite popular in the local market, but she wants to go have a more bigger business. Okay, she want to expand the business, okay, nationally or internationally, right? And the best idea in today's market is to have a mobile app where everybody can see what are the sorry yeah so what is she selling, right? And they can order it and she can ship it anywhere in the world, right? So it's a really inspiring idea, right? So based on that concept, she thinks of creating a mobile app and making a bigger market, but she's not so sure about the mobile app development process. Okay, how to do that? Okay, it needs a team of developers, testers, system admin, security, database. So many things are required. She is not aware about all those things, right? So she approaches a company, okay, a software consulting firm. Okay, this organization is specialized in creating software from an idea, right? So Penny explains the idea to the team, the business consultant, and the idea that she has, right? And based on that idea, the development can start, right? So the concepts first. So software development process will start now, and software development process is really a very well organized and a well defined process. Okay, special protocols over here, right? So first step or phase is requirement gathering, right? So Penny will be giving all the requirements, and all the requirements will be gathered by the business consultants. What will be the product features? What are the who is the target audience? How they're going to use it? Okay, user requirement. How you're going to sell it, right? All the requirement is gathered, plus the system requirement is gathered. What tools and technologies will need to develop this product, right? That's the first step. Second phase is based on the requirement that is gathered in detail. The planning starts where the requirements are analyzed, the cost, resources, and risk associated with it is calculated, right? And a detailed plan is created, right? Now, based on the plan, the third phase is design phase where the architects will design the product. There will be different kinds of architect: the software architect, the network architect, the now infrastructure architect, the security architect. There will be different architects that who are going to design the product. Okay, as the architects does, they create design documents, right? They are not going to develop the product, but they're going to create the design, right? A vision, and this vision is given to the developers who based on this vision develops the software, right? And they write thousands and thousands of lines of code by using different technologies and creates the software. After the software is created or some part of it is created, there will be a quality assurance team which will make sure they test the product thoroughly before it goes to the real user, right? If there is any defect, any bugs, okay, it will be pointed out and it will be fixed by the developers, right? If the quality assurance team gives a heads up, okay, then it goes to deployment. Then the product is deployed to the real servers, and the system admin operation teams teams in the operations world will be in charge in delivering this product. They'll be shipping it to the servers and from there to the users, right? And the operations and system admin team will make sure it is continuously monitored, always up and running, right? So there will be continuous with that. There'll be once the product is hosted online, people are using it, let's say the mobile apps is being used, then there'll be regular maintenance, okay, regular changes and uptime needs to be taken care, right? So based on the user requirement, or maybe there is a bug, so that will be fixed. So there'll be regular changes, and operations team also need to make sure the system is always up and running. Okay, so that's how they make business. Right, let's see that in a cyclic view now. So you have first requirement gathering, okay, then comes the planning, Then the designing, where the architects will design the product, developers will develop the product, okay, writing all the codes, testers will test the product, and then operations team is going to deploy and maintain the product. Okay, and there will be then regular changes, and the cycle goes on and on, right? It's in a cyclic view. Now, this is called a software development life cycle. If you are from an engineering background, you already know this, right? If you are not, you know it now. Okay, software development life cycle, in short, SDLC, right? And there are different models in SDLC. You have waterfall model, agile model, spiral, big bang. These are just some set of rules that how you're going to do the development. Okay, SDLC is there. When SDLC are different types of SDLC, right? You can think of this as different types of SDLC as different route to reach the same destination, right? We are driving somewhere and you want to reach to a place, and there are different ways to go there. So you will choose a route based on various factors like distance, risk, cost, benefits, maybe not benefits, but yeah. So based on different factors, you will decide a particular route and you'll select that route and reach your destination. These models are also like that, right? So we are going to compare difference between waterfall and agile, and very well you will know why. We're talking about waterfall model first. Okay, waterfall model works in phases. Okay, requirement gathering is the first phase, and waterfall model first phase needs to be completed to go to the next phase. You can't jump in waterfall model. Okay, so if there is an idea and you need to create a product, so all the phases needs to be completed, then only the product will be available to use. Okay, so first requirement gathering completes, and then it goes to the next level, and designing completes, it goes to the next level. Okay, and that's why it's called as waterfall, right? So water is full over here and then it goes to the next level, then it goes to the next level, like that. Okay, so in requirement gathering, design, implementation, which is development, testing, and then maintenance. Now there are some issues with waterfall model. First of all, as I said, it's going to take you have to complete you have to complete all the phases to have a working piece of software, and it may take months to create the software, right? And it cannot accommodate regular changes. That's the biggest problem, actually. Today's market is continuously evolving, regularly changing, right? The requirement changes. So when the requirement changes, based on that, while the development is happening, while this SDLC is going on, we need to do some changes, which is not possible in waterfall model. You need to complete everything and then only you can accommodate new changes. Okay, so it doesn't scale too good in today's time. Now when this is explained to Penny, okay, Penny says that I'm not sure about all the requirement at once. Okay, I'm new to this. I don't know how it's going to go, so I would like to observe the product development and then maybe alter or add new requirements, right? So waterfall model is a no-go, and in today's time most of the requirements are like that, really changing requirements and fast development. Okay, I want to see my product before even it gets completed in the development phase, which is not possible in the waterfall model. Okay, so it lacks the feedback loop. You can't give the feedback while the development is happening. So the Swiss organization decides not to use waterfall model, but to divide the requirement into smaller iteration instead of developing all the features at once. Okay, the requirement gathering collects the features. You have a list of features. So developing all the features at once, instead of that, let's divide it into smaller lists. Okay, you can call them iteration, right? An iteration could be a time frame 2 to 4 weeks. The first iteration, you're going to develop some features, show it to the customer. If the customer is good or not good, based on the feedback, we go to the next iteration and alter the requirements maybe, right? So here you're going to get continuously you'll have feedback loop. Okay, so you are not waiting till the end of the product gets completed. You develop some feature, show it, it's good, you continue, it's not good, you make changes, and then you continue. Okay, so dividing into smaller iteration, this is called as agile SDLC. Okay, the word agile means quick, and that's what agile SDLC does. Okay, it quickly gives you a working piece of software which you can demonstrate to the customer or the client and get feedback. right? That's the most important part actually, right? If you are already a developer, you will know how important it is. If you're not, once you get into DevOps, right, or whenever you work with the development team, you will know how important it is to get regular feedbacks. Okay, so hey, can you mute yourself for now? I'll take your question at the end. Thank you. Okay, agile SDLC is in iteration, not in phases. Okay, so 2 to 4 weeks could be an iteration. Sometimes you're 2 weeks, sometimes you're 3 weeks, sometimes you're 4 weeks. Okay, uh, so demonstrate to the customer gives the feedback, and then you can alter the requirements in the next iteration. Okay, that's pretty awesome actually. Right, now let's understand, we understood SDLC now, difference between waterfall and agile. And agile is the way forward. Most of the organization you go, their development will be happening with agile. Okay, and why we are talking about this, you will understand that in a moment now. So when the development is happening, okay, there'll be regularly build. So developers will write the code. Okay, they'll continuously be writing code, and they'll be testing the code, and they'll be creating a build, which is actually working piece of software. Okay, and the build, they'll test it first in their local environment, right? If it's good, not good, based on that, they're going to select the right build, and they will send it to the staging environment. They'll say, hey, you can take this build, this is a working build. So in staging environment, it is tested more further, right, by the QA team or other teams, UAT team. So it will be tested more further in the staging environment. Once that build is good, then it can be promoted to the production environment. Okay, this is in short build and deploy process. In short, there's so many things that happens, but for understanding now. Okay, so developer will be continuously writing code and building it. Out of that, they'll select one build which works best for them, and then they promote it to the next level. Then next level, finally it goes to the production environment where the real user will be using it. Okay, now, well, while this is happening, this process, build and deploy process before production. Okay, so software testers will be testing it, right, in the staging environment. There's so many times the testers will not be able to access the environment itself, or their tests are failing. Okay, the infrastructure is not accessible. Right, this is a regular problem that comes in. So when this happens, the deployment is done by the operations team. Okay, so operations team will be contacted that, hey, the deployment that you did, the last deployment, it failed. Right, and the operations team will be like, hey, I deployed it as per the requirement, as you wanted me to do the deployment. I followed all the steps. Okay, and here the things will go back and forth, and this will be continuously happening. Okay, this is a problem before it goes to production. Deployment failing, test cases failings, and operations team will be blamed for that. Right, and similarly the issue will come later for the production issues. Production also, somehow they patch it, fix it, and send it for production, and then sometimes in productions also it fails. Okay, hey guys, just pausing it for now here. Now, can you please drop your mail and contact number in the private chat, in the organizer chat, not the public chat? Okay, so my team can contact you, okay, for the documents, for the book, and everything. Okay, please drop it in the organizer chat. Do not put it in the public chat. Okay, in the chat, select the organizer and put your email and number. Okay, so things are failing in test environment, and then later things are failing in production environment also. Okay, now why is that? Developer has promoted it, saying that it is a working piece of software, but still failing. Right, so there could be so many reasons. So let's talk about few reasons. Just a moment. By the time you put your mail and phone number, I'll take a pause. Okay, let me resume then. Okay, so the deployments are failing in production environment also, or non or QA environment also. It is working in dev environment, but it's failing there, the other environments, right? When it's getting promoted, and the reasons is first of all, the operations team is going to deploy the product, uh, assuming that it's going to work as it worked in the development environment. Okay, but then there are differences. The two environments, prod and non-prod, are different and not periodically synchronized. Their database could be different. Okay, their data, file based data could be different. The version of the softwares, right, there are so many softwares involved in creating a product, so some version changes will be there, different versions. Dev did not inform about all this to the operations team, and for that reason these environments are not regularly synced. So if it works in a dev environment, there's not a guarantee it's going to work in prod, because prod environment is little different now. Okay, it's not continuously synced. Also, the new development process and tools is making the development very fast. In today's time, really, I'm so amazed. The development is so fast. I remember even a decade back also, it used to take a very long time to develop a piece of software, but today, so fast, right? But operation team is not able to cope up with this regular change. When the development is happening, that means it needs to be delivered. Product created needs to be delivered. So creation is so fast, but the delivery is slow. Okay, and which is hampering the operations. Work environment, work ethics. Okay, they're doing trying to do fast deployment, which results in a lot of time failures. Okay, production servers, as we said, are not in sync, so it needs some tweaking, right? A version change of a software, a change in the database, a change at the OS level or at the network level, firewall level, security level. At different level there needs to be some tweaking that needs to be done so many times, which is not informed by the dev team to the ops team, right? And so that's why the product is not working, right? So there could be multiple reasons. The main reason is actually communication gap. They're not able to convey how it's working in dev environment. Okay, so no clear instructions. So ops teams sometimes have to figure out, okay, you have already working in IT industry, the troubleshooting, if it's done in the ops team, it's mostly about hunch, guesswork. Try this, try that, shut down this, restart that, reboot that, expect it's working. Okay, because the clear instructions are not there. Okay, now we have to understand the moral, okay, or the summary, that code changes, there are regular code changes because of agile has made the development very fast. Regular code change means regular deployment means regular testing. Okay, and frankly all this is not, operation team is not able to cope up with all this. Okay, the deployment will be manual, it will be error prone. Okay, inconsistent environment. Okay, not repeatable, right? So because of this continuous hampering on operations team, they are not able to handle it. Okay, there's just too many deployments, man, right? I remember the time when we were into the situation actually, right? And we used to think that dev is too smart, and people used to think that ops is too dumb. Okay, but that was not true. All right, it's just because of we'll understand it's because of what. Okay, so my point, operations team, the development is very fast, operation team has to do regular, clear instruction. They're already occupied with the production uptime, which makes the business. Okay, and most importantly, they're ITIL process driven. From a long time, operations team is ITIL driven. That means their proper process, how to make a single change. Okay, I remember the time when for a single production level change, it used to take 5 days. It was so simple that probably just make some line of changes and restart some service, but that used to take 5 days. It was not incompetency of the operations team, it was the process. So many approvals, documentation, showing them into a non-prod environment, right? Of getting approval from customers and the monitoring team, and then finally doing the change and the scheduled downtime. Okay, so because of the process, the operations was slow, not because of the competency, right? But in between all that is happening, the failures are happening. fixing, the customer is really suffering. So Penny is the one who's taking the hit. Okay, she is expecting to see some result, but it's always getting postponed. Okay, the project had passed the deadline so many times because of this problem. Okay, they want to demonstrate to the customer or maybe ship it to the production, but because of these regular failures, okay, and fixing, the deadline is passed, right? So this starts the problem of development versus operation. Okay, development versus operation. We're still not there at DevOps. Okay, so developers are agile. Okay, they are agile process driven. Operation is ITIL driven. Agile means regular and quick changes. Okay, agile word itself means quick, right? And anyways, the process itself is like that. Okay, they'll regularly create the softwares, make code changes, but ITIL is the other, pole. Okay, one is north, the other one is south pole, right? ITIL is about stability, right? Slowly, carefully documenting approvals and then making the changes, right? So they are two poles apart, really. And it's popularly said that the developer will just toss their code over the wall. Operations team has to just deal with it. Okay, like write the code and just toss it, right? I'm done. Okay, handle it, do the production deployment. But frankly, there are, I have worked with a lot of developers, right? I have faced these challenges a lot. Okay, they write the code in their IDE and all, and they just send the code. I'm done, right? But there's so many requirement that needs, right? How to deploy this, which server, what version, right? But because of this previous waterfall thing, right? In agile, it's the same thing now. They write the code and toss it over the wall, right? So development versus operation, you will hear this complaints if you worked already in IT industry, that developer will say that the operation teams take very long time for the deployment. Operations team will say, they have just given me some half-baked code, man. Okay, no clear instructions. Okay, it will not be so formal. Okay, they'll be saying so many words. But anyways, so this happens. Okay, they fight with each other. It's like Tom and Jerry, right? Can't live without each other also, and can't and can live without each other. Anyways, understood the point, right? Tom and Jerry. So development versus operations. Now again, in between all this, let me remind you again, the customer is suffering. Okay, passing the deadline, customer is not able to access, the users of the customer is seeing errors. Okay, problems because of this. Now this means a direct business loss. Now, okay, let's give him name as Dinesh. Okay, Dinesh. Okay, it's the MD maybe. Okay, and it's taking the hit right now. Customer unsatisfied customer means business loss, right? But Dinesh, I just took a name from the chat now. Okay, so Dinesh, remember there was an agile conference, okay, which he has attended, where it talked about DevOps, how all this problem can be solved by DevOps. Okay, now this is a real thing. Okay, there was an agile conference, and the guy who presented the talked first about DevOps was Patrick DeBois. Okay, he presented the idea of DevOps. He said development is agile, it's fast, yes, but the operation is still waterfall. They are still slow, step by step. Okay, so doesn't matter how fast you create the software, you're not able to deliver, you don't make business, right? So you can combine these teams or process, right, and have DevOps, right? So Dinesh remembers that, and then he tries to rope in a DevOps consultant who can fix all these problems. So now you understood the problems. Now we'll talk about the solution. Okay, so enter the DevOps consultant who promises that he can fix all this. Okay, skyrocket the business, make lots of money, and blah blah blah. Okay, I was just trying to be more creative. Anyway, so DevOps consultant comes in, but it's not, the DevOps consultant doesn't have a magic wand. He will just do something and everything will be fixed. It's not like that. Okay, DevOps consultant brings in all the teams together and explains that the DevOps is about communication, collaboration, and integration. So all the team needs to communicate very well, collaboratively work together, and integrate their process, tools, and technology. we'll understand that what that means. Okay, these are heavy words, but they really mean, they're very, very important. Okay, trust me, I have seen so many projects who try to implement DevOps and they fail. That's because they focus on the tools only. Some focus is only on the concepts, processes. Okay, but it's not just tool, it's not just automation, it's not just process, it's not just integration, it's all of it. Okay, so watch this. The DevOps consultant explains development team and make them understand the operations. It's very important for a developer to understand how the system admins, how the operations team, how the cloud engineer works, what are their job roles, what do they do. Okay, and the focus is more on stability. You can't be just tossing your code regular continuously and expect them to be working. Okay, you need to be more informative, right? So in a DevOps, you need to bring parties together and you need to understand, the developer needs to understand the operations. Okay, and the other way, he also visits the operations and explains them the development. What is SDLC, what is agile, how there are regular meetings, there are bug fixes and features. And okay, so he tries to bring in the operations team and development teams closer. Okay, and they can only come, the conflict can only be resolved if both parties understands each other. Okay, nobody is right or wrong, there's no right or wrong. Okay, the work is the work, right? So conflict will be resolved only when they understand each other. That's how any conflict is resolved. Okay, so explains operations team about agility. You can't be so slow in today's time and doing so slow deployment. You need to be faster. Okay, and so he brings in all the parties together and then explains the most important concept of automation. Okay, once they're communicating, they'll be working together. They will be in one agile team, not separate teams. There'll be one agile team where you'll have developers, testers, build and release, DevOps, system admin, whatever. Any team that is involved will be has to be working together, and it's the responsibility of a DevOps consultant to rope in everyone. Okay, and then he explains the concepts of automation. Everything that we are doing, that you're doing manually, needs to be automated. I remember back in 2013, 12 or 13, okay, end of 2012 and beginning of 13, I was working in an organization and suddenly there was a movement of automation. You know, automate this, automate that. And there were trainings happenings. People were writing codes and using tools, and everybody in every team was working on automation or doing automating their work and task. Okay, so code build process, how the code is built, that should be automated. Code testing process should be automated. Software testing should be automated. Any infrastructure changes. Okay, now back in 2012 and 13, we already had VMware and all those things, virtualization. So the infrastructure can still be automated that time. Okay, automatic VM setup and network changes automatic, disks changes automatic. So infrastructure level changes automatic. Automatic deployments, right? When the developer creates the software and builds and tested it, then it needs to be automatically deployed. Okay, frankly, okay, it's not fitting in a slide. Okay, everything needs to be automated. I have taken this screenshots from my animated video. Okay, I'll give you the link, you can watch the animated video. Okay, everything, frankly, everything needs to be automated, right? And then that's how it happens. Development operations team decides to be working together in an agile team. So if when you are also in this picture, when you are a DevOps, when you get into a project, you'll be working in an agile team. You'll not be a separate DevOps team, you'll be working in an agile team in a project where you'll be having developers, testers, operations, everybody. Okay, and you will be the glue to connect everyone together. All right, so you will see the sharp, the smart, the intelligent meet the Avengers. Okay, just joking. So the here our Avengers are um, build and release team, developers, testers, system admin, database admins. Okay, anybody who is involved in creating and delivering the software will be in the DevOps team or in an agile team, you can say. Okay, so DevOps is not a separate team. So everyone work together and decides to automate everything. Okay, they work day and night. Sorry, kidding, not night, mostly days. Okay, they work on automating everything and then integrating everything. It's not just about automation. You automate everything and then you start integrating things to create a DevOps life cycle. Okay. The idea is to have a DevOps life cycle. Like you have SDLC, Waterfall SDLC, Agile SDLC. Now the idea is to have a DevOps life cycle. DevOps lifecycle is like this. Okay, everything automated and then integrated. Once the developer creates the code, there will be an automated process that will start, that will build the code and create the artifact, the softwares. Okay, then the code will be tested automatically. Unit test, integration test. Okay, this will be all happening automatically. Code analysis, vulnerability assessment, all the best practices. These things will be conducted automatically. Then the code will be delivered to different servers, okay, for further testing. Any database changes, security change, or any kind of change, okay, all those things will be done automatically. Okay, so there will be tools and scripts in play that will be doing all this one by one, step by step. Okay, then automated software testing starts, which will test the changes and give the result. If everything is good, there can be an automated deployment to production, but that depends on requirement again. Okay, so deploy to production automatically. Okay, go live. The user traffic is diverted to the new changes. If the user approval, if user is giving good feedback, then it's kept, otherwise it can be rolled back. So there will be automatic rollback also. Okay, and continuous monitoring of the entire process. This, my friend, is DevOps life cycle, and this is what you will be hired to do. Okay, once the developer writes the code, automated process you should be having. You can build the code, test the code, analyze the code, deliver the code changes. Any DB security change automatically. Software testing scripts should get executed automatically. Deployment to production. Okay, all this. You must have seen this diagram so many times when you search about DevOps on Google, right? Okay, this is an infinite loop. Okay, so it's a continuous process, right? There'll be regular code changes, so regular testing, regular delivery, regular analysis, right? So this is a continuous process. Okay, continuous process, an infinite loop. That's why it's used in DevOps, because it's continuous process. As long as the project is there, there'll be changes. If there are changes, it needs to be delivered automatically. Okay, this is one more view. This is a diagram where I try to throw some tools over here to make you understand through a tools perspective. So a developer makes a code change, and let's say they're using Git to store their code. Okay, then there could be an automation tool like Jenkins, which can fetch the code, build the code, run some test, and store the software into software repositories like Nexus. Okay, now Jenkins is a tool that can integrate with various other tools like build tool Maven or Ant or Gradle, or it can integrate with Docker to build Docker images. Frankly, if you're not understanding the tools, don't worry. Okay, it is for people who know these tools or heard about these tools. You'll understand what tools fit where. Okay, if you don't know about these tools, don't worry, just understand the process. That is enough for now. Okay, so Jenkins is an automation tool which will fetch the code, build the software with build tools or build images, store the software in repositories like Nexus Sonatype. Okay, it's a storage, and make the changes in the environment or provision the environment in cloud computing environments like AWS. Okay, automatic changes, infrastructure level changes, probably launching VMs or making changes inside the network related changes, storage related changes. Okay, any other kind of changes. Deploy once the environment is tweaked, changed, then take the software artifact and deploy it to different environment by using automation tool like Ansible or Puppet or Chef. Okay, and deploy it in different environments like dev, QA, staging, and then finally production. Okay, and while this is happening, there will be load test and functions test and security test, different other kinds of test also. Okay, so again, the same DevOps life cycle, but I try to throw some tools over here to make you understand. Again, it's a continuous process. You see that circle there, right? Push the code, build the code, test, upload, deploy, load, test, push, a continuous process. All right, so in this you have continuous integration also, in this you have continuous delivery also, but the whole process is DevOps life cycle. Okay, I'll give you a link of continuous integration, continuous delivery, animated videos. Watch them and you can understand what is CI/CD as well. Okay. Now, in sometimes we also used to call it as one-click deployment, that a developer just makes a code change and clicks somewhere, and then all the process, starts automatically and finishes automatically in its automatic production deployment. Okay. Now, DevOps by definition is difficult to define. Wow, that's a nice sentence I used, huh? Yeah, but still, people will would like to know the definition. If you're interested in definition, this is the definition that I personally like. Okay, I found it on some site and I liked it. Okay, DevOps is a philosophy of unifying development and operations team at culture, practice, and tools level. Okay, so what is DevOps? Well, it's a philosophy which wants to combine the development and operations team at culture, practice, and tools level. Culture, like agile culture, right? Fast, quick changes, regular deployments. There are practices that are involved. The tools, and developer tools integrating with the operations tool. Why? So we can achieve accelerated and more frequent deployment of changes to production. So for continuous changes to the production environment, okay, giving the user the best and continuously giving them, right? So you need DevOps. And DevOps is a philosophy. It's not a tool, it's not a technology, it's not just also a process. It's a philosophy that involves communication, collaboration, and finally integration. Okay, so being a DevOps, your job is not just to write scripts, guys. It's about orchestration, combining all the things together. You will not be in charge in automating everything in a life cycle. Some pieces not. Like for example, software testing. Being a DevOps, you're not in charge in writing automating software test cases. Okay, software testers will do that. Your job will be to integrate that with your build life cycle. Okay, that's one example. Like that, there's so many other things which you will learn in the course. Okay, now what are the skill set that you need in today's market to do all this? You're interested now, right? Come on, let's do it. It looks interesting. It's also highly paid. But what do you need to know? Okay, you need to have systems knowledge, like operating systems knowledge. You should be very good in Linux. If you're using Windows, you should be good in Windows also. But more, specifically, you should be good in Linux. Infrastructure knowledge, okay, understanding the networks, ports, protocols, storage, all right, shared storage. There's sort of so many concepts, right? Network, firewalls, in a complete infrastructure. You should know, you should have a broad infrastructure knowledge, what fits where, how it works, like that. Okay, cloud computing skills, definitely in today's time, mandatorily you need to have cloud computing skills if you are DevOps. Okay, and the reason is this: actually, cloud computing gives you a way of automation. Okay, you can automate infrastructure that was not possible with physical infrastructure. Okay, that's one. Second is 90% or more of the IT industries are using cloud computing. Okay, so you need to know cloud computing. Okay, and that's why our course is half part of our course is really cloud computing and also automation of that. Development SDLC knowledge, the whatever I explained, plus I'm going to give you some few things to read. You need to understand the SDLC, and more, you will be more comfortable with that when you work with the developer. The first project, be very close to the developers, take them out for treat. Okay, no, just kidding. Okay, just regular no, attend regular meetings, understand the developments. When you get into the project first time, it will be a golden opportunity for you, if you're not a developer, to work with a developer, to understand their process, right? Trust me, if you don't understand different teams and how they work, you will not be able to set up DevOps lifecycle. Okay, trust me, I tried that. Build and release automation, or also called as continuous integration. You should be very good with this, and this you will know only if you know developers and how they work. Automation of operating system tasks. This is system admin side. System admins are going to execute a lot of system commands. Okay, you need to know how to automate them. Okay, orchestration of continuous delivery process. So how you can integrate all this automation together and have a complete DevOps lifecycle orchestration. Okay, executing all of the automation in a proper order. Network and security knowledge should have if you're going with cloud computing, definitely. And containerization by default in today's time. Even if you're not an expert, you should have some knowledge on Docker or any container technology. Okay. So these are some DevOps skill sets in today's time, right? And it may change, but I don't think most things will change. Okay. All right. So what are we going to do on this course? Okay. You'll get this slide also. Don't worry. You don't need to take any notes or anything for now. Okay. I'm going to give you the entire, all the slides and this video, everything you will get. Okay. If you have not dropped your mail and phone number in the organizer chat, please do it. Otherwise, you will not get this and books and some videos that we're going to share with you. Okay. All right. So now let's talk about course coverage and let's wrap up the demo, make you understand what we're going to do in this course. So I'll run real quick. Then you have questions. I can come back. Okay. So we are going to do it like a pro. We have a project to do it like a pro. Pro means professional, right? So if you want to really work into DevOps project in real time, you should know the challenges, and the challenges you will only know if you have a project. So for the course, we have created a project vProfile, which is a Java project, and which is going to give you challenges. You have to build it, deploy it, automate it, do so many things with this project. Okay. So this project has many services: Nginx, Tomcat, RabbitMQ, MySQL, Memcache, Elasticsearch. So you will know how to set up this manually, then automate this, then how to do deployment on all this. Okay, we're gonna then how to containerize it, how to put it on cloud, how to host it for productions. Right. So with this project, we're gonna take a lot of challenges, and that's how when you get into a real project in the IT industry, it will be similar thing. So you would already have gained experience in the course itself. I know most of you don't have the real time experience in IT industry or in DevOps. Okay. And this course is an opportunity for you to get that real time experience. Okay. No, Srinivas, Windows, no, because it's already too much on the plate, but I will help you understand same thing for Windows. Okay. Being a DevOps, you should be able to automate anything, including Windows, and it's not big deal. Okay. Once you know how to do automation with Linux, the same tool you can use to automate Windows. There'll be different modules and different steps. That's all. Okay. All right. So first we have first step is basics of Linux and server management in Linux, Vagrant, basics of networking, and the vProfile project setup on VM. This is stage one, step one. This is prerequisite of our course or any DevOps course. All right, you should know all these things so you can learn the other DevOps tools and technologies. Right. So step one is for people who are from non-ops background or new to IT industry who does not know anything. Step one is very important and crucial for these people. If you're already a system admin, you will already know all of this. Okay. But if you're not a system admin, then this is very, very important for you to go through. Okay. So step one is really eligibility of our course. Right. Once we do that, once we set up the project on VMs locally, then we are going to go to AWS. Okay. Also, I have also one more way. We can start with bash scripting after this, but then that will decide in the course based on your understanding. Okay. Few things can be twisted as per your understanding. All right. How you're catching, how you're doing assignments. Based on that, we can also tweak the course path. Okay. Which to do first and second. But in generally, then we'll have cloud computing. We're going to learn cloud computing, AWS cloud computing services like IAM, EC2, EBS, load balancers, S3, CloudWatch, RDS, auto scaling, Route 53. Okay, once we learn these cloud services on AWS, we'll move our project from VM to AWS cloud. Okay, we'll set up the project on AWS cloud for productions. And while we are doing that, we'll learn few more new services like Memcached, Elastic Cache, okay, CloudFront. These services also will be learning. Okay, I'll come to your question, Rajshekhar. Let me just wrap this up first. Step three, once you're good with the infrastructure and all, then we are going to learn version control, Git, GitHub, build tool, Maven. Continuous integration will start. We are going to learn Jenkins in detail. Jenkins as a build server for testing and deploying, master slave concepts, and other tools also we're going to learn with this, like Nexus, SonarQube. Jenkins CI pipeline as a code, right? Jenkins administration, and we are going to do continuous integration for our vProfile project then, okay? Which will be something like this, right? So Jenkins will fetch the code, do code analysis, create the artifact, and deploy it to staging environment and production environment. Once you learn the automation of CI/CD, then we are going to step up our game and we are going to learn bash scripting. Now, bash scripting, as I said, we can take before AWS also, and it is recommended. That's what I recommend. But again, based on your understanding on Linux and networking and all, we'll decide then. Okay. But we can take it later also and before that also. Anyways, we have bash scripting, so we're gonna see basics of bash scriptings, and we'll also see how we can write scripts to automate day-to-day admin tasks. Okay, system admin task in Linux. Wait, what? Where is Python? What happened? Oh, just a moment, guys. Where did that go? I think I accidentally deleted a few things. Let me just get it. Okay, yeah, Python scripting. Okay, so Python scripting, in Python scripting we'll be seeing basics of programming. Python programming, we'll see variables, data types, conditions, loops, functions, modules. Okay, and we'll see how we can use Python to do OS automation. We'll be also learning JSON and YAML. That is also not okay. Anyways, okay, then we start with Ansible. Okay, once you have gained knowledge in scripting, which is good for people who does not know programming and who are scared, right? How I'm going to survive in DevOps, I don't know scripting, I don't know programming. Okay, so this step 4 is for people like you, and also for everybody who wants to learn more detail into automation tool like Ansible. So scripting, once you get good hands on scripting with bash scripting and Python scripting, then we'll start Ansible. We'll learn Ansible in great detail. Okay, we'll see several modules. We'll understand what is YAML and JSON first. We're going to write a lot of playbooks for doing automations. We're going to learn concepts like variables, conditions, loops, handlers. Okay, there'll be variables deep dive. We'll see Ansible roles. We'll see how we can use Ansible to do automation for AWS. So we need a lot of automate manual task for AWS. We'll see how we can automate that with Ansible. And then we are going to also deploy our vProfile project automatically by using Ansible. Okay, so that's step 5. Okay, so deploying a vProfile project with Ansible and also using Ansible to set up AWS. Okay, then we have part 2 of AWS. Yes, AWS is not done. We have part 2 of AWS where we'll get more in detail into AWS. We're going to get into a VPC in depth, log management and custom metrics. We'll be seeing AWS CLI, S3 CLI, command lines of AWS. Beanstalk and RDS together. We'll see a project with Beanstalk and RDS together. We'll be then learning how to do CI/CD on AWS by using code commit, code build, code pipeline service. Okay, so CI/CD with Jenkins we have seen. We'll be also seeing it on AWS. Okay, AWS Route 53 routing policies, different deployment strategies, blue-green deployment, A/B testing, what are that? You will understand that. Okay, so we'll be doing one more CI/CD project, as I said, by using all AWS services. Okay, then finally we are going to learn Docker. We'll understand the Docker concepts, what are containers, okay, different concepts in Docker. We'll build images for a vProfile project. We'll containerize vProfile project. We'll be learning Docker Compose to run multiple containers for vProfile project. Kubernetes will start then. We'll see how we can set up Kubernetes for production environments, EKS service, different Kubernetes objects like pods, services, controllers, deployment, replication controller, auto scaling, resource quota, secret, config map, namespace. So many Kubernetes objects we'll be seeing. And then finally deploying our vProfile project on a Kubernetes cluster for production. Okay. Okay, so in containers, we have first containerization of vProfile 1 project, and then deploying this containerized project to Kubernetes cluster. That's another project. Okay. All right. And I would like to remove this workshop. Now we are giving you videos. We have videos for workshop videos for Terraform, AWS securities, and CloudFormation. Okay, so this I'm going to give you the videos of it because it's too much in the course. We can't cover everything. But I really believe that you should learn these technologies also. Once you're good with till Docker and Kubernetes, then the next thing you should be learning is Terraform, CloudFormation, AWS security. So I'm going to give you videos for that from the workshops, and you can learn these technologies as well. Okay. All right. So that's the end of the demo, guys. So let me just remind you the course USP. I focus on real-time implementation. We have projects to implement our skills in DevOps. You're going to get assignments and collaboration we'll be doing on Google Classroom. Okay, assignments is again requirement. I'm going to give you assignments and see how you respond back. Based on that, I'll give you more or less assignment. Okay, it all depends on you. And if you have lots of material, I have written a book, Decoding DevOps. You're going to get this book after the demo. We have a lot of documents and scripts and code that you will be getting on regular basis from Google Classroom. Okay, and Facebook group where you can sign up for any new updates. Okay, whatever new updates we are getting. Okay, but most of the collaboration will be happening from Google Classroom. All right.
Hey, thank you very much for watching the video. You are awesome. Join me for more awesomeness. If you like the video, press the like button, subscribe for more latest update like this, and hit the bell icon so you get constant updates.